Start here. So, let's talk about some more problem stuff. We've already done some of it. Let's go over the two formulas that we should already know that we've gone over. The first one, I'm going to write them up here because you don't have them on this sheet, is going to be the compound n times. So that can be monthly, or daily, or weekly, or twice a year. That formula is going to be A equals P. And that's it, A equals P. No. Psych. Okay, so this is the final amount. So I'll kind of go over this. So this is the final amount. This is the starting amount. R is the rate. R is always the rate. I'm not going to write that down. T is always the time. I'm not going to write that down. N is the number of times, which I kind of already did up here. N times. So if this is monthly, what does N equal? 12. If this is weekly, what does N equal? 52. Oh, shoot. If this is biannually, 2. Quarterly, 4. Daily, it doesn't happen daily, but 365, unless it's a year that's got a multiple of 4. I don't really, just do 365. Okay? The other one is going to be the compound continuously. The compound continuously is going to be A equals P e to the RT. Stuff we've already done, but now we have everything we need to memorize all together in one little part of this paper. Okay? Alright, we're going to be going over exponential growth and decay. So here's your formula. Is y equals C e to the kt. Looks very familiar to the compound continuously one because, well, it really is, except compound continuously talks about money, and this just talks about stuff that's growing or shrinking or whatever. So just kind of be aware that with these problems, sometimes you're not given the C value and the K value. You need to figure it out, and we'll go over that today. Also, you have the half-life model, okay, which is written as this. Almost the same thing as some of the stuff you see up here. Pretty close to it. Difference is, instead of an E, it's a 1/2, and then it's T divided by K. K is the half-life amount. C is the initial amount. T is always time. And K is the rates. Alright? We're not going to go over all of these. You don't have to. Try to go over these pretty quickly. So, like the first two examples, we do not need to do because we've already did stuff like that. So let's go ahead and go down here to number 3 here. So we have we want to find radioactive decay of this isotope. I don't really care about it. We know what its half-life is. We want to know the amount. Or no, we know the amount after 1,000 years, and we need to find everything else. Okay. So here's my formula. So I'm looking for the initial amount. I don't know that. That's why that's blank. So I can't find that, but I can find everything else. What's Y? 1.5 equals C 1/2. What's my T? 1,000. And what's my K? So what you're going to do here is you want to get C by itself. How do you get C by itself? Just divide everything else. Okay? So all I'm going to do is I'm going to divide by this 1/2, this number. So C is equal to 1.5 all over 1/2 to the... You literally just go to your handy dandy calculator for the rest of this. Do you need me to show you how to do this in the calculator? It just takes one yes. Any yeses? Yes! Oh, okay. Alright, I'll show you. Yes, I get sponsored by this company. I'm not allowed to mention because it might be a pirated company. So all you're going to do is I make a fraction by hitting that alpha F1 and then 1.5 all over, and then it's going to be 1/2 raised to the 1,000 divided by 1599. Yes, it vibrates every time. If I'm holding it up in the air, you don't notice it. It's on the ground. Alright, so it's my initial quantity. So it's going to be 2.31. Did I do it wrong? Okay. 2.31. You can do 1.3 or 1.4. I don't really care. Which one do you want? 4 to make you all happier. What's my label? Grams. Wasn't that such an exciting problem to do? I'm so thrilled.
Save the bees.
Alright, number 4. Find the exponential model. Gives us the model that fits these points, 0, 1/2, and 4, 5. What that means is I need to find C and find K. That's all it is. And then some of these questions that we'll be doing, you'll be given this to find C, find K, so you can find a third thing. So when we find C and find K, all you're going to do is plug in your initial values. If there was ever a 0, I plug that in first, because that's the easiest thing to ever plug in your calculator. So, in this case, this is Y, and this is X. So, I'm going to plug in for Y, I'm going to plug in a 1/2 equals C e to the K times 0. Now, why is 0 so special? Because K times 0 is 0, e to the 0 is... So C is equal to, which is the initial value anyway, so I didn't even need to show you all that work. So now my equation is Y equals 1/2 e to the kx. To solve for K, I have to plug in the other value. So this is my other X and my other Y. Let's go ahead and do that. So 5 equals 1/2 e to the 4K. Solve for K. What's the first thing I do here? Very good, class. Divide by 1/2, which is the same thing as multiplying by 2. 10 equals e to the 4K. I'm going to go ahead and loop this, just a backwards loop. ln of 10 equals 4K. Solve for K. And I'm going to get K to equal ln of 10 all over 4. This one does not require a calculator, by the way. All I wanted me to do is just solve for K, and then I'm going to rewrite that in now. So Y equals 1/2 e to the ln 10 over 4 times X. I wish we could simplify this more, but the notes tell me not to do that, because we could actually simplify this more because of exponent rules, but whatever. Good enough for me. Let's do 5. Same problem, but now with actual words and a whole meaning to doing it. Zoom out a little bit. Oh, we're talking about art. Love it when I talk about art and math. The value in millions of dollars of a famous painting can be modeled by V equals 10 e to the kt, where t represents the year with t equals 0, corresponding to 1990. In 2004, the same painting was sold for $65,000. Find the value of k. Use this result to predict the painting value in 2010. Okay. So I'm given the C value. That's kind of nice. The C value is worth 10, which means that in 1990 it was worth $10 million, by the way. So in 2004, what's my T value in 2004? T equals 14. And when T equals 14, what does V equal? Just 65. Remember, it's in millions, so it's just 65. So plug this all in. I'm going to get 65 equals 10 e to the 14k. Divide that each side by 10. Am I going too fast? Good. I know that reduces, but if I'm going to find k on my calculator anyway, do I really need to reduce it? You don't need to. So loop it. I'm going to get ln of 65 over 10 equals 14k. Divide each side by 14. What is ln of 65 divided by 10? Divided by 14. Do I need to do that for you on my calculator or no? K equals what? 0.0. 0.1. Oh, 0.1. 3. 4. And there's more. I do that ... because that means I still need this value in my calculator. I don't want the 0.134. That's shorthanding it. I want the entire thing. I'm going to show you how to store this on your calculator, so I guess I do need to go through this. I mean, you don't really need to store it, and I'll kind of show you why, but I'll show you how to store it, because that's a good skill to have. So when I do this, ln of 65 over 10 all over 14, that gives me the value. See this button that says STO between the 1 and the 4? Stow. You want to stow that in whatever letter. I'll just pick the letter. And by the way, you see these like green, you guys can't really on mine, but on yours probably can. Store it into K, and then I'm good to go. And I can always rewrite that out. And then I can just press K. Alpha K. That's the only way to get the K. It's the alpha. So now we have Y equals, not Y equals, it's V. So I know the value in 2010. So V equals 10 e to the k times, what's the value I want for 2010? 20. So k times 20. So what you're going to do here is you're going to do 10 e to the k times 20, and it'll give you the value. Now, did you need to store it in K? Let me show you a way to not store it. I'm sure you all know this anyway, but hey, I'll just do it for giggles. So e to the, you can just go up and literally pull what that value is. Yeah, you just use the arrows and you go up.
You know, fun fact, I've always freestyled it. No matter how long it was, I just freestyled it.
Yeah.
Yeah.
You do you. So V is equal to 144.97. I don't really care. You want to round it? I want to round it, for sure. And this is millions of dollars. There it is. Good, because I'm going to confuse you more. 6, I'm not going to do it. Just another different. It's just a formula. All right. Not too worried about it. Let's go to. I love 1995 stuff. I love it. That's all we do is talk about the 90s. Okay, so the population of a town was decreasing according to the law of exponential decay. In 1995, population was 50,000. 2005, it was 44,000. What's the expected population in 2015? So we kind of get to manipulate this problem however we want. So we do know it's going to be y equals c e to the kt. I'm going to use t for time. What does y represent in this? It's population. Okay. Can I do this in thousands so I don't have to type in all those zeros? Are we cool with that? Okay, cool. We're good. And what does and t represents what? Time starting at what? 1995. Do you want t to be 0 at 1995? Sure. So let t equal 0 be 1995. I'm not picking anything weird here. I'm not like, oh, let t be 5 be 1995, because that would really stink. And because then you have to do a lot more math. So in 1995, the population is 50,000. Isn't c my initial value? So what's my c value going to be? We were doing it in thousands. So y equals, is that what you're getting at? Okay. 50 e to the kt. So I already used this. Because t equals 0 gave me the 50,000. What's 2015? What's t equal? 10. And that's in 2005. And then, what does y equal then? 44? Let's use these numbers, 10 and 44. So here we go. So 44 equals 50 e to the 10t. I need to recover the lost souls. Okay. This is my 2005 statement. 10K. I hate pen. I blame the pen. No one's buying it? Good. You're not supposed to. This is my 44 represents the population again in thousands. Oh, that was the confusion? Oh, okay. 50 is the initial population. E to the 10 is the time in 2005, and then I need to solve for K. Still need to solve for K here. So I'm gonna get. Can I just do some like real quick math here? And tell you that that's K. What value do we get for this? Anybody? Or do I need to do it? I see Daniel doing it. I bet you K is negative because it's right when it's a negative rate. Negative 2 point. We're not getting that. Ruh-roh. Let's try that again. Somebody else. Daniel, what'd you get? And then I'm gonna write ... That means I have to use all the information. Store it. Oh, we had a parentheses issue?
Yeah.
Those parentheses. Alright, so to find what's going on in 2015, what does t equal? 20. So y equals 50 e to the k, I have that, times 20. 4?
Hold on.
Oh, he gave me the 4 sign is for hold
I
on.
had a pen in my hand, so I couldn't.
Oh, okay.
You lost.
It's fine. I'll track back right through this problem.
I think you got. Like that.
Somebody else doing it, or do I need to do it?
38.7.
30 what?
38.7.
0.7.
It's 719. 720.
Okay. Don't be so angry. Alright, let me backtrack this a little bit, help explain this for some people that look a little lost. In order to get here, you need a helper equation. You need to know what K is. So you need a helper. Here's your helper information. In 2005 it was 44. That's my helper information, which is why I did this statement right here. You use this to solve for K, because there's too many variables here. In the initial equation, I have 2 variables I need to solve for. Luckily, the word problem gave me the initial, which is 50. That's why I have a 50. I need to use the second piece of information to solve for K. That's my helper equation. So I do all that work. I solve for K. You can either leave it like this or store it. I don't really care. You come back here and you type in the information you need to answer the question. Okay? Alright, who wants to talk about puppies? Me neither. We're done.